Hi, Purushat.
Hi, Srinivas.
Yeah, okay. So, hi, friends. Good evening. So, welcome to the domain analytics training by 360DigiTMG. So, up to now, we have discussed regarding applications of marketing analytics. Next, we discussed about project management methodology, that is nothing but CRISP MLQ. Then we discussed regarding exploratory data analysis and data pre-processing. Okay. In coming to applications in the marketing analytics, we discussed why data science is very important towards marketing analytics, and what is the effect on marketing analytics so by the data science. So it is helpful to promote our product, and what are the approaches, etc. We discussed it in the first class. Then project management methodology. So any machine learning engineer, if he has to take one project, he need complete guidance. So that guidance is nothing but CRISP MLQ. So we discussed regarding CRISP MLQ. So in CRISP MLQ, so we discussed that there are 6 phases. So first phase is nothing but business and data understanding. Next step is nothing but data engineering. In business and data understanding, the project, whatever it may be. So first we need to understand the business problem. After the first step, business and data understanding. After understanding the problem, then what are the business objectives and constraints we need to highlight, and we need to focus on the objectives. So the business objectives are nothing but measurable things, so which will increase our product, which will help us to reach our target. Yeah, what are business objective of the problem, and what are the constraints, what are the limitations we need to find. And then we need to check the project scope as well. So after, we need to discuss about data engineering, comes under data pre-processing, cleansing. And yesterday that things we discussed. So data pre-processing and EDA comes under graphical visualization. So based on the graphical visualizations in our data, do we have any outliers, or do we have any NA values and etc. If data having outliers or NA values, it is very difficult in the stage of model building. So if any outliers or NA values we need to find, then we need to minimize that by the techniques, data pre-processing techniques. So these are the things we discussed yesterday. Today, let us start with machine learning, types of machine learning. As I explained already in the second day, 4 types of machine learning: supervised learning, unsupervised learning, reinforcement learning, and semi-supervised learning. So today, let us understand what is unsupervised learning. So unsupervised learning is nothing. It is a machine learning technique in which models are not supervised using a training data set. So I explained already one simple example. So here machine don't know what will be the output. Machine don't know about the input data. But when we pass our data, it will give some pattern. So it will segment our data. It will give some patterns, etc. Like when there is a bucket consisting of various fruits. When we pass such data to the machine, so it will separate. So based on the features, it will separate like mangoes, apples, and it will make into the clusters. So same thing will happen here. There is no output variable. We will pass the data, then the total data will be converted into the clusters. So based on patterns, trend. And we will focus here unlabeled data we use. So unlabeled data means we cannot find, like if you want to know the cost of the building, if there is no feature related to cost of the building, even though you need to find. So in that way, okay. So examples of unsupervised learning. Okay, clearly I'm saying we will give the data, output is nothing but some patterns. So after whenever we can, if you want to, if you share new data to the model, so it will predict that the new variable what we are adding is belongs to the which cluster. So it is belongs to what cluster, it will give us. Now examples of unsupervised learning. Here you can see input data. If you see the picture, input data, so we are sharing the different, so different things we are sharing, but I can see a pattern. So based on that, the model can understand some pattern. So it consisting of 3 patterns. So machine split into 3 patterns. You can see here. And in second and third picture, when we pass the data, so data consisting of so many points. The total data points are separated into the clusters. So based on similarities, etc. So this is the example for unsupervised learning. Next thing. So why this clustering is very important in marketing analytics. So marketers are commonly use cluster analysis to develop market segment for better positioning our products or messaging. Like just which products are commonly purchased. So which products are purchased, and we have different age groups. Okay, why clustering? We have different age group like 20 years and 30 to 50 and 60 above. These are the age groups. And let us take products A, B, C, and which product, so which age pattern or which age groups are purchasing that particular products, etc. So based on that we can, and similarly we can promote, so based on their interest, so that we can understand by their features. Okay. So position is nothing but a placing object. Say you will go to the Walmart or any store. Okay, and Walmart or any store, they have the data. So they notice it that the people whose age is around 25 to 30, they are purchasing more. They are spending money on notebooks and some stationery. So what they will do, they will place yeah, because the concentration of the age group is more in that particular store. And similarly, there will be some particular places reserved like that. So if there is a demand, laptops, so laptops having the huge demand, headphones are having huge demand, so they will place, so each and every person can access easily like that. Suppose there is a product, no one is purchasing that product, so no need to place, there will be some particular place where they can able to see and etc. So some decisions they can take based on the data. Okay, and our historical data says that the person who will purchase a pen definitely purchase notebook. So then what they will do, they generally books and stationery, everything it's same place only. But you cannot expect pens are placed in one place and books are etc another place, like that. Some analysis. And we can say and people are during the pandemic time. So what happened? So people are habituated to watch thriller series. Okay, so now what they can take any OTT platform. So they can recommend, they can spend money on who are ready to direct such type of short films or movies, because even if any thriller series, they may have more interest like that. And based on age group, suppose children, so what they are watching, like that they can take some decision based on the data. Now in unsupervised learning, it is also nothing but clustering. So we have so many clustering technologies. Clustering is nothing but splitting the data into the clusters like pods. Many types of clustering we have, but here we will discuss k-means clustering. So what is k-means clustering? So it is unsupervised learning method, and same group similar data points into clusters. So it is completely based on centroid based algorithm. So here some steps we will implement. So many methods. First we need to initialize k value. K means clustering. K stands for initially we will choose 2 or 3 centroids. Then what we need to do, just we need to find the distance between the data points. Suppose there are data points, I can show. You can say data, this is one data point, data point. Yeah. So here you have 2 data points, here 3 data points, here 3 data points. Now you can make into 3 groups. Here it is one group, it is another group, it is also one group, like that. So first we will decide 2 centroids. That value we can choose, and by after choosing the centroid, what we will do, we will find the distance between the data point to the centroid. Okay. Then after calculating, what we will do, just we will change the centroids. Then again we will find the distances. So in this way we will, this is nothing but iterating process. So we can do continuously, and if there is a situation that it is not changing, then we will decide that centroid as clusters, and we will divide the data like that. And to choose k value, what is k value in k-means clustering? There is a one more method, is nothing but elbow method. So anyway, I can explain after completion of the theory. I will show in Jupyter notebook. You can understand what is elbow curve, what is the graph, and etc. So elbow curve, elbow method, so which is used to find k value in k-means clustering. What are the steps are involved in the k-means clustering? Let us discuss. So first we need to initialize the centroids k for each sample in the set of samples. Next, assign sample to closest cluster k based on the Euclidean distances. Initialize the centroids. Then what we will do, there are data points. So many data points we have. All data point we will choose any 2. Then what we will do, for each and every centroid, the distance between the data point and centroid we will measure. Then after that, what we will do, we will reassign the centroids. Again, recalculate the distance between the new centroids and already data points. So repeat these steps until and unless stopping a criterion is fulfilled. Like just if same value we are getting, then we will stop. Yeah, Euclidean distance, nothing but distance. There is a formula. If 2 points are there, there is a distance. like one formula under root of x2 minus x1 whole square. We have studied in mathematics, right? If 2 points are there, the distance is nothing but x1 coordinate, y1 coordinate, x2 and y2. So under root of x2 minus x1 whole square plus y2 minus y1 whole square. So that is the formula. Use it to find the distance. And we will find the variance at each cluster. And we will find sum of square distances. Repeat this process until and unless without changing that centroids. Okay. So this is the iterating process. So simple words I can say. First we will choose two or three centroids based on our data. Then what we will do? We will measure the distance between data point. So we will measure the distance from each and every data point. Then what we will do? Just we will change the centroids, and we will see. So in particular situation, while we are doing this process, there should not any change between the last two processes or three processes. If there is no change, then we can finalize that clusters. So in that way, data is split into the groups. Now, what are the advantages of k-means clustering? So it is the most used clustering method, largely due to being computationally inexpensive, and it is applicable for the large data. So if you have the data having 1 lakh observation, 50,000 observation, so this k-means clustering is applicable. And it is also appropriate method to know the number of cluster from the data set. So SSE stands for sum of square error. So it is the distance between data and cluster center. Find the distances. So the sum of square error should be minimum to choose the cluster. Okay. There are still any doubts you can ask.
Sir, regarding the selection of K, you said we'll be using elbow curve to select
that I will
K,
show.
right?
Yeah, correct.
And
that I will show in hands.
In the advantages, it is saying that when number of clusters to be drawn, it is an appropriate method when you know the number of clusters to be drawn from the data set. So does it mean that if you know the K value, then also we can do it, and if you don't know the K value, then also we can do it. That is the case.
If you don't know K value, we can go for a Euclid method. So not only that method, elbow method, we have the various methods. Various methods are there to find the K value in k-means clustering. And so one of the methods, tell me.
And the sum of square errors that we are calculating, it is the difference from the K value, right?
Yes, correct, exactly.
Okay. And in the end, there was a statement called n underscore init. The previous slide, there was a statement.
Okay. One minute.
Repeat steps 1 to 5 with different initialization of the cluster centroid positions. So what is that n init times? N times means I understand. Until
init is nothing but iterating initializations.
Okay.
That sentence is not fulfilled. Okay, right.
Okay.
Initializing. And I mean, the intention is nothing but iterating process.
Okay. Sir. And when we don't know the number of clusters that we have to select, we'll select a range, and from in that range we'll try to identify the best.
Exactly. Yes? That we will do in we will select a range and we will do. I will show hands-on. I will show in that.
Okay, sir.
I will select the range and I will show which value we need to take with elbow curve and etc. Everything, because that's why I will cover more in that hands-on.
Okay, sir.
Yeah, thank you for asking. So next, limitations. So limitations are nothing but Yeah, first one is number of clusters must be chosen upfront. We need to first either we need to choose clusters or we need to select the centroid. That is a choice. And outliers can have a strong influence on the results. If our data having the outliers, definitely it will show effect on our result. And initial centroid positions is strong influence. I mean, I am saying that initially we need to choose the centroids, right? So what we are choosing, it will show effect on the results. So it completely based on, so that is comes under one of the limitations, and does not cluster well with clusters of varying sizes, density. If the densities are changing, like we may have one DBMS, density based clustering and opting, various methods we will use. So in that case, we will not use this k-means clustering. That is the limitation. If the density is varying, it is not applicable. In that case, some other limitations, other like density based clustering we have, that we will use. So these are the limitations from the k-means clustering. Next, key concepts, just stability run k-means clustering is multiple times called as iterations with a different random chosen k value, and with k value sum, just we will find iteration, etc. Nothing, iterating process, repeating process. So until and unless to get the proper results. So this is about k-means clustering. So simple words I can conclude. It is unsupervised learning. Unsupervised learning means just we don't have the output variable. The data what we are sharing, it will be split based on the feature. So machine understand pattern based on the data, historical data. Yes, one of the clustering method is nothing but k-means clustering. First we will choose the k value, then two centroids we will choose. It should be iterating process. Sum of squared error, that should be minimum. Like that we will split the data into the clusters. So this is k-means clustering theoretically. So now I will go to the hands-on. Here you can understand clearly. So what is k-means clustering? Yeah. So first our problem, the use case is nothing but customer segmentation using k-means clustering. Customer segmentation means just we need to classify the customers. Like we can say age groups, maybe low age groups, middle age groups, old age groups. Their purchasing behavior also different, that we know very well. And how much this is the data from German credit data. German, just how what is the credit limit, what amount they need to pay, that is with respect to the ages, low age, middle age, and age above 60, like that. So this is the business. Actually, this option I'm not getting here. Okay, just I will explain, don't worry. Yes. So first we are loading what are the necessary libraries we need. So use case is nothing but what we are doing here by using k-means clustering. The data having the age groups. So lower age group, middle age group, and older. And their credit value. Based on this, we are splitting our data into the clusters. So first what we need to do, we need to import the what are the packages are required, like import pandas as PD. So pandas for data frame application. So if you want to work on data sets or data frame, pandas compulsory. NumPy we need to work, Cbound for visualization, Matplotlib also visualization, and sklearn standard scalar The standardization, normalization, we need to do. Next, min-max scaler. These are very important. Yeah, just annotation. We can. Any doubts are here? What is warning? Yeah, warning is nothing but while we are working with the Jupyter notebook, what will happen? It will show some warnings. Something you need to check. It will not error. Some warnings will get. So I don't want to get such type of warnings while I am executing that code. So I use that warnings. So generally, while we are working with Jupyter, if you do some label encoding or anything, you will get. Okay, so I don't want to get. That's why. So these are the packages. Just I am executing. Some color. I am giving some preference for my colors as well. That's why I have used color mix as well. Yeah, it is done. What packages are required to work on this algorithm is done. Now I need to load the data. Yes, done. Now what is the?
Hello, sir.
Yeah, tell me.
Why we use one hot encoder here instead of one hot encoder? Can we use that label encoder?
But preferably we can use one hot encoding.
Sir, what is the
Both
reason behind?
That's fine. What one hot encoding? What it will do? It will just we have three variables. We will take suppose three one hot encoding means just what will happen? The number of columns will increase. So label encoding means what we have. Suppose 4 cities: Hyderabad, Bangalore, Chennai, and Pune. So Hyderabad will take 0, Chennai 1, 2, 3. So based on some concept. But preference is one hot encoding.
Okay, okay, okay.
Okay. See, just what will happen? The total categorical data is converting into the numbers. Then, if you do some analysis on that, we may not, because we are choosing the value based on sequence, right, etc. Generally, one hot encoding will be most used one. Yeah. Any doubts, please? Yeah, thank you. Now I have loaded the data set. Now, what is the data? You want to see? Just type data. So this is the data. So try to understand what are the columns. First one is, so unnamed, nothing but it is nothing but index only. It is looking like an index. That's why it is unnamed. And age of the customer, and gender, male or female, and job. So here, yeah, it is label encoding only used. Job, housing own, saving accounts, yeah, little, moderate. Next, checking account, and credit amount, how much they need to pay, duration, radio or TV. So I mean, some age people, they will purchase one product with some credit. So in how many months they are paying, and that person is belongs to which age group, like. So we are in that pattern, we are dividing our customers. So that is our problem here. Is problem is clear or any doubts here? Please let me know. Our data having some NA values and etc. that we will do anyway in the pre-processing. Yes. Next, I want to do auto EDA. I explained all yesterday. I am using pandas profiling. Just I will run this. Just auto EDA helpful for understanding the data, or at least it will give some guidance how to proceed. It is done. I will show that file. So 1 minute. Yes. So number of variables 10, observations 1000, total missing cells percentage, etc. So what are the variables? This total auto EDA. So with one line we are getting this all. Housing, job, saving accounts. So in which column we have NA values, outliers, everything we can get with this. Simply that okay, correlation plot. Each column, what are the missing values and etc. So this is about auto EDA. Missing values only. Yeah, let us go to our code. So auto EDA is completed. Now data.head, I know already top observations you will get, and some I want to give some styles to highlight. That's why these I use it. Color, blue, some properties, font family, cursive, and etc. These are data.head is for to see the top 5 records. So remaining for highlighting them. Okay, you can see unnamed, age, gender, job, housing, and etc. Now data set information. So total rows are 1000 and total columns are 10. And what are the columns? We have unnamed and what is the data type? Age, sex, job, housing, etc. So this is the data set information. Now, anyway, the column 0 is unnamed. So that is nothing but index only. So I want to, I'm feeling that anyway, that column is not helpful for my analysis. So I want to drop that. Suppose if you want to drop that column, you need to use data.drop. Done. Now, next time, just we need to print the categorical columns. So we have categorical column, sex and housing, saving accounts, checking account, purpose. And what are the numerical columns in our data set? Further, just you can execute this. So numerical columns.
Yeah, we've been here. Sir, the codes that you executed it on those were custom codes, right?
Yes.
Are there any libraries available that we can get numerical columns?
We have so many.
Okay.
Yeah. So many things are there, but here I'm choosing this is the best method to explain the segmentation. Yeah, methods are so many, but choosing based on our interest, our idea, and etc. So many factors comes in. Yeah. So this is simple thing I'm doing. First, I have loaded the data set. Then after what I did, just I did some EDA, auto EDA. I want to some idea I will get. I'm not proceeding with auto EDA only. Just data set 1000 rows, right? 1000 rows and 10 columns. So instead of seeing each and every observation, then viewing that EDA part better. That's why I have chosen that. Now next, let us start with the descriptive statistics. Yesterday I have explained descriptive statistics, analyze the data set by the graphs and etc. Some interpretations. Now in inferential statistics will give inferences based on descriptive statistics only. Yeah, it is giving descriptive statistics So what is the count? These are all comes under statistical measurement. Count, mean value, standard deviation, minimum 25%, 50%, 75%, maximum of value, etc. Next, let us go with statistical graphs, visualizations. Yeah. Now, age distribution. Our business problem is customer segmentation, meaning different age groups and different credit value, etc. So that 2 points you remember. So this is box plot, histogram plot, age distribution. So in our data set, we have outliers. It is clear. And age, so 20 years. Starting from 20, yes, 70 above. Then we are calculating the skewness and etc. Again, box plot, variable, color, plot size, job distribution, histogram. Just if you run, you can get. Yeah, this is again some job distribution, box plot. It is not clear because the data, some noise, I think. Histogram plot. And credit amount distribution. EDA we are doing on some features. So how much time they are with the, I mean, how much time they are clearing them. So duration distribution. Okay, so here they have taken some columns, they analyze it. So with respect to statistical visualizations. Now correlation map, heat map. So what is the relation between each and every column in our data set? Yes. Yeah, age, job, credit amount, duration. Okay, they are only considering these four only. Age, job, credit amount, duration. Because they want to separate into cluster based on these features. And I'm setting some colors, labels, order. Yeah, male 690, female 310. So male and female, right? That one. Next, pie chart for the gender classification. And here I'm using drop NA method. So to remove outliers, I notice some amount of outliers in our data set. So I want to drop that. Let us run. So after the values are changed. Housing, own housing, rent, and free. They may have some free housing, I think, in that country. This is about pie chart. Some visualizations on savings accounts. The savings account. These are the classification savings accounts. Saving account is a column. So in that column, little savings 603%, moderate is 103, quite rich 63 and rich. That histogram you have seen, and pie chart as well as. Next, checking account. It is nothing but deposit account. Yeah, coming to, they can withdraw money, deposit account, like bank accounts, we can say. So little 274 and moderate 269, bridge 63. Yeah. Next, purpose. Yes, correct. Because one variable only we are taking, right? So purpose, I mean, they will purchase like this total nothing but we will purchase something in EMIs, and age group, which age groups are maintaining high EMI number, which age groups are maintaining many months, etc. Who are maintaining short span, like that. So purpose, why we are we want to purchase car or TV and some furniture, etc. And total missing values in each columns. Yeah, so age of, but we have missing values in savings account. Next. So I am just what NA values are present in checking account and savings account. Just drop NA. Done. Now, if you want to see the missing values, yeah, we are not having any missing values, and data is pre-processed. So size for all figures, just you can see here. So visualization of histogram plot with respect to age and total, and credit and total, and duration and total. Yeah, age and yes, same, credit and duration. Skewness of the distribution has been resolved by performing the transformation. So transformation, log transformation is performed here. Just simple method. You may ask, what is again log transformation? So nothing but transform the skewed data into the normal data. Next, feature engineering, we'll use one-hot encoding to convert the categorical features into numerical columns. Yeah, here one-hot encoding is used. Yes. Now all features are numerical. Then you can see the data, categorical features, age, job, item, everything in the numerical. So here columns are increased, see 26. So up to here, data pre-processing. Now, just we are going to our topic, K-means clustering. And age, credit amount, duration, features for K-means clustering. Meaning, so we are segmenting the clusters based on age of the person, and credit amount and duration features. Okay, next. Yeah, any doubts here, please? So before K-means clustering, do you have any doubts? Please let me know. Yeah, now scaling is done. Just standard scalar. We know already standardization is nothing but subtracting from the mean and dividing the standard deviation. Yes. So now it's time to elbow method to use to determine the optimal number of clusters in K-means cluster. Okay, we have chosen the range. Somebody asked, correct? Just in between 3 to 15. Now we will have some cluster and we will get elbow curve. Based on that, we will choose. It will take some time. So this is the elbow curve.
Sir, how can we choose that K values from elbow curve?
Yeah, just it will looking like elbow, right, at a particular value.
Yeah.
Elbow, like, so can you tell me now at which value you are getting elbow?
Between 4 and 6.
Yes. And here you have, so one of the algorithm also used here, Silhout algorithm.
Sir, that is our K value.
Which one?
Between 4 and 6, that is K value. How can we take K value from elbow curve?
Just where we are getting elbow, you can take, so here,
Okay.
you can take here 5. Okay.
Yeah.
You can take, okay, 5 is better. 5 you can take K value. See at 5. 4, 5, 6, 5, it is better, I think.
Yeah.
Not exactly, just range also we can take. 5 is the better here. Where we are getting that elbow, a name indicates that. So here the points I added that I want to show. Yeah, I think here, yeah, we have only, yeah, I did with only 3 clusters. But 5 also you can take, not a problem. Generally, we will take K is equal to 2R. Yeah, we can take with 5, you can take with 4 also you can take. There not a meaning that, yeah, you will get some value, you need to take the particular value, some ranges. because one of the method we are using. Here I can, yeah, I have seen, yeah, 3 clusters I use. And this one I want to explain here. Silhouette algorithm. It is also one of the algorithm to determine the optimum number of clusters. And here it is some different. We already assumed that it should be the data is for only some particular number of clusters. The elbow method, you elbow curve you have, but some different method is used. Okay, please understand. And you can so what we did is just we assumed, yeah, we can make our data into the 3 clusters. That's it. Yeah, let us run this. Yeah, so if in 3 clusters, the score is equal to 0.30. For each and every cluster, what is the score? For 4 clusters and etc. Now, after that, see here. So this is the cluster data. And if you see here in this 0.2624, 2625, yeah, so 0.30 for 3. So max is Silhouette score they chosen to decide the clusters here. Okay, we are getting some issues because of some noise data as well. Yeah. And we need to import k-means to find k-means clustering. Oh, it is done. Okay. So now the total data, already I informed we have taken 4 columns to apply k-means clustering, that is age, credit amount, duration, and cluster. We can remove, but even though there will be a possibility.
Sir, how can we find out the noise in that data?
Yeah, based on the results,
Sir,
we will get. Tell me.
Yeah, which result? Based on which result?
See, you have seen elbow curve. Okay. Now, actually, we have chosen 3. 3 is the optimal number of clusters, but that curve is not exactly showing that 3.
Okay. Based on that, okay, we'll.
Yeah. So it should become exactly. It should come exactly, but we are not getting. So why we are not getting? There will be some issues in the data. And one more thing, we are already clear with the auto EDA, right? So in auto EDA, just I have shown you some lot of challenges are there in the data. So that is the problem. Okay, see the missing cells percentage 5.8%. Generally, it should be below 5. Okay. And we used it, and one more thing, we have taken only 4 columns, not total. Okay, so while we are doing what we focus it, just we are reducing the column size and we are trying to implement the clusters based on some selector feature, and we are not applying for all. Yeah, that's why we will get this.
Sir, how can we remove that noise?
We can remove in the pre-processing only actually, but even though sometimes it will, generally it will be removed in the pre-processing only. And that's why this is a challenge with unsupervised learning. Okay.
Yeah. Okay.
Yeah.
Sir, Vipin here. Sir, by noise you mean outliers, null values, all that, right? By noise you mean all this, right? Outliers, null values.
See, noisy data is nothing but a large amount of meaningless information. Okay. So data corruption, term and etc. So many things will come, sir. Not only outliers.
Okay.
Okay. See, there is a data related to the cost of the building. Something is added, like. Yeah, okay,
Sir,
let us go with, tell me, no problem.
Sir, if noise will present in data, then it will definitely affect on the result.
Confirm. So the thing
Yeah.
is, yeah, my just listen to me. So it is completely the everything you are getting. It is because of the data, right?
Yeah.
So the data issues. Okay.
Sir, then it is needed to remove that noise first in preprocessing.
Yeah, we can remove, and don't mind even if you remove everything. And I have explained in CRISP-MLQ methodology. After that, we will test, and some noise also required to know the performance of the model.
Oh, okay.
Yeah, these all will consider.
Okay.
And I explained already. I think you remember or not in CRISP-MLQ also. So what they will do, the model is now giving good accuracy around 97 or 96, etc. Then we cannot say, right, the model is 96 or 97 accurate for new data. Now we will build model. I'm not saying with respect to this unsupervised. From tomorrow, we will start with supervised learnings. Okay, you can understand in that. Now 97, yeah, model building is done. We are having accuracy is equal to 98. Now what we will do, just we will apply to the real data. So when we apply the data, are you thinking still it will give 97%?
No,
Will you think just, yeah.
You are talking about accuracy, right?
Yeah, yes, that one only. 97 accuracy we have with our data, what we have. Now what I will do, same concept I will apply to the real data. Are you thinking same 97 you will get?
No, it may be.
It may be or may not be, right? We cannot say.
Yeah, right.
And even okay, if new data you tested, testing also done, it is giving 97, fine. Are you sure same in future also it maintains 97%?
No. If data will add in that one or noise, it will definitely reduce that accuracy.
Okay, not a problem. Just if any doubts you have, just you can clarify in tomorrow. So let me finish. We have 3 minutes of time.
Okay.
So please keep asking such questions. That's better. I feel some interest. Okay, keep asking. Now, finally, we have grouped into the 3 clusters and age, credit amount, and duration. See here, points are added. Cluster 0, cluster 0, cluster 2, 3 groups. Our data is separated into the 3 groups. So one is higher credit amount and middle-aged long duration customers. Second one, lower credit amount, older short duration customers. And third one, lower credit amount, young generation. Just I did not get information. Anyway, we will join tomorrow. So 100% I can give the information. I think you can get, I will inform tomorrow. I will share where you can get this data and code, everything. Okay. So thank you, friends. Just today we discussed about. Sure. I will tomorrow. What I will do is just I will share the references where you can get the data and where you can get this use case, everything. And finally, we segmented customers based on these 4 features. Okay, we will, and tomorrow start with supervised learning. So thank you, friends. Have a nice day. So any doubts, please keep asking. You ask tomorrow also, not a problem. I can clarify. Then we can continue. Okay, thank you, friends. Have a nice day.